All right, here we go with part two. I had to pause there because the girls um, thought there was some exciting thing that they needed to show me. All right, so back to this. Which of the equations below is balanced? You should always make sure you write this out and do the counting atoms chart, if you will, but we're just going to look at this real quick. So we have 3 here, 3C here. We have 8 hydrogen for 8 hydrogens, so those check out. And then 4 times 2 gives us 8 oxygen. And then over here we have 3 times 2, so that gives us 6 plus 4 gives us 10. So not this one. 3 carbon, 3 carbon, we have 10 oxygen, so over here we have 3 times 2 is 6, plus 4, that gives us 10, and then 8 hydrogen, 4 times 2 is 8. But you should always go through and do the inventory. All right, question 11. The important thing when you look at problems that look like this, that ask you what's the mass of the gas produced, is that the law of conservation of matter states that matter can't be created or destroyed. So pretty much what you see on one side, you're going to see the same amount on the other side. So what you're going to end up doing is just finding out 140.2 minus 137.2. So basically right now you don't even really have to do the math looking at these, because you know you're not going to add them. You're not going to end up with just the number for the reactants or just the number of the solid. You're going to end up with this, because whatever I have over here needs to add up to what is here. All right, let's take a look at this. Based on the graph, which one is below is correct? As water temperature increases, solubility decreases. So that would be saying that as the temperature gets higher, these lines are going down, and they're not going down. Then our next one, as temperature increases, solubility increases. So that means the lines would be going up, which they're doing. But let's double check our other two. As water temperature increases, solubility increases then decreases. That means it would look like that. So no. As water temperature increases, solubility decreases then increases. So that would be a down, up, V. So it's not that one. All right, a change in the state of matter from a liquid to a solid is an example of physical change, chemical change, an endothermic reaction, or chemical bonding. All right, so we're looking at a change, so we're going to automatically get rid of these two. So if I look at water and I freeze water, is it still water? Yes, so it's not going to be a chemical change, it's going to be a physical change. All right, 14, a chemical heat pack like hand warmers gets hot after the reaction has started. What kind of reaction is this? All right, so this one gets hot. Hot has 3 letters, like the prefix. What do you think? Exo. So exo is hot. All right. And then we can automatically get rid of these two, and it's going to be exo. All right, both boxes are made of pure iron. This goes back to something we talked about more at the beginning of the year. They're pure iron, so their densities are going to be the same, because the density of iron, no matter how much or how little you have, is always the same. All right, question 16. A chemical reaction that absorbs thermal energy and gets colder is, well, cold has 4 letters, just like the prefix endo. We haven't talked about iso or meso, so right away cross that out. And then exo has 3 letters, so it is hot. Which, here we go. It's kind of a duplicate almost question. Chemical reactions that release thermal energy so they get hotter are your exo. Don't get confused with this thermal reactions and the word thermal here. (18). So we have a graph here. Which object in the table has the greatest density? So remember that it's mass divided by volume. So 11 divided by 24. We have 11 divided by 12. We have 5.5 divided by 4. And then 5.5 divided by 11. All right, so this one, I would always prefer that you do the math and use a calculator. But 11 is kind of close to 24, so that would be 1/2. So it's about 0.5-ish. This 11th, 12th, so close to 1, almost. This is going to be greater than 4, so think of it almost like a fraction. So it's going to be over 1. And this one's almost 1. And then 5.5 divided by 11, that's going to be about 1/2. So our greatest density would be Y. All right, which of the following statements is true about the neutralization of an acid by a base? The pH goes to 0. 0 is the strongest acid you're going to get, so nope. Organic compounds are end products. Nope. Organic is hydrogen and carbon. A gas is an end product. Nope. Our end products are always a salt and water. Which of the statements below demonstrates a physical property of matter? Copper reacts with oxygen in the air and turns it green. So that's a color change, so we know that that's chemical. Lemon juice is acidic. Chemical, so we just learned about acids and bases. Paper clips can be picked up by a magnet, and sodium reacts with water. All right, so we have a color change, we have acidic, and we have reaction. So our physical property is going to be the use of a magnet. What coefficient number must be placed in front of the O in the chemical equation below to balance it? This was one of the enhanced questions where you actually needed to write a number. So we have 4p here, 4p here. So what do we need to do to this oxygen to make it 10? We have 2 over here. So we need to put a 5 here so we can multiply it. All right. The picture shows 500 ml of milk in one flask and 500 ml of water in another flask. Which conclusion can you make about the physical properties? The density of milk is greater than that of water. Milk has a greater mass. Milk and water are soluble fluids, or the milk and the water have the same volume. So the only thing we can tell is that they have the same volume. We can't answer any of this just by looking at the pictures. All right, which of the following properties are bases? It tells you that there are 5. So you need to check 5, not 4, not 6, just 5. So bases are bitter. Now look, litmus paper, red or blue. Acids are going to be your red. Neutralizes acids, feels slippery. Forms hydrogen when in water. It has a pH greater than 7. All right, so we have one more. No, it's not this. No, it's not this. Not this. Not this. All right, we have this tricky one in here. Neutralizes acids. So remember that when you combine a base with an acid, it becomes neutral. All right, which of the following values are acidic? So that's anything less than 7. So we have 2.7 and 6.1. Another type of question that they like to ask on the SOL. Question 25. Which of the following examples are physical changes? Choose the 3. So 3, not 2, not 4, 3. Salt dissolves in water. Solubility is a physical property. Rusting, no. Candy bar melting, yes. Your candy bar is still a candy bar. Not burning wood. Tearing a piece of paper, it's still a piece of paper, just a little bit smaller. And not this. So there is our 3. Which of the following is a chemical property of matter? Not density, that's physical, because that's going to stay the same. Not magnetism. Reactivity and hardness, not hardness. So it's going to be reactivity. Always make sure you're going through and crossing out the answers that you know are definitely not it. Which of these statements describes a chemical change? A lake freezes solid. So the water in the lake is still water, whether it's liquid or frozen, so no. Gravel, sand, and water are mixed. I can still separate those out. A copper ball is rolled into a flat sheet. So that's just saying, is it malleable? And it's still copper, whether it's in a bar or in a flat sheet. So we end up when calcium chloride mixes with baking soda, the temperature decreases. You actually did that experiment. All right, 28. This is asking you about water displacement. So for water displacement, you always start with the ending volume and subtract the beginning volume. So it started with 20, we add the rock, it's now 30, so we're just going to do 30 minus 20, which means that our rock is 10. Remember, you'll see centimeters cubed and 1 ml used interchangeably when talking about volume. After a substance goes through a chemical change, the number of atoms is less than, the same, more than, or dependent upon the temperature. So remember, there's always the same number on the left side as there is on the right side, so it's always going to be the same. Why is it important to know the physical properties of matter? Well, you definitely want to be able to identify the substance. You want to be able to classify it. And you want to be able to know the uses for it. So it's going to be all of the above. 31. When hydrochloric acid and zinc combine, zinc chloride and hydrogen gas are formed. This is an example of a chemical reaction, a physical change, photosynthesis, or evaporation. All right, so we're going to get rid of evaporation because we're not talking about that here. We don't have hydrochloric acid and zinc in photosynthesis. So physical changes like ripping paper or changing from solid to a liquid, So we don't have a physical change here, we have a chemical reaction. All right, so we have a density question. First, you need to find mass and volume, so mass divided by volume. To find volume, we do length times width times height. So 3 times 2 is 6. 6 times 4 is 24. All right, so now we have 12 divided by 24. You could look at this like a fraction and reduce it down. It would be 1/2. Putting 1/2 into decimal form would be 0.5, and it's grams per centimeter cubed. 33. When an odor occurs, bubbles are produced and the color changes. What kind of change has taken place? All right, appearance, no. We have not gotten to phase changes yet, so no. So physical or chemical? Physical, it's still the same substance, so no, it's going to be a chemical change. All right, how many grams of CR will be formed? So remember, it's just going to be the same on each side. So we have 76 plus 27. All right, 6 plus 7 gives us 13. We carry the 1, 8, 9, 10. So we have 103. So now we do 103 minus 51 gives us 2 and 5. So we end up with 52 grams. All right. 35. Why does the regular soda sink, but the diet soda floats? The can of regular soda is less dense than the can of diet soda. The can of regular soda is more dense than diet soda. The can of regular soda has a larger volume, or the can of regular soda has a smaller volume. So they're the same size can, so they're going to have the same volume. So if it's going to float in water, that means it has a lower density than water. If it's going to sink, it means it has a higher density. So the can of regular soda is more dense. All right, 36. Corn, syrup, oil, and water were poured into a container. They settled into the layers. We have oil, water, and corn syrup, which is correct. All 3 liquids have the same density. That's not going to happen because they're all separated into different levels. The corn syrup has the greatest density down here at the bottom. Oil has the greatest density. The density of water is more dense than the corn syrup. All right, so remember, lighter density up top, higher density at the bottom. So your corn syrup has the greatest density. All right, the 2 beakers below contain pure water. Which property is the same for both? All right, so we have 2 different amounts, so it's not going to be mass. We have 2 different volumes, so it's not going to be volume. Weight's not going to be the same. The thing that's going to be the same is density, because no matter how much or how little you have of something, the density always remains the same. Which of the choices below is correct? So we want to know which one's gas, which one's solid, which one's liquid. This is nice and uniform, nice little rows and columns. So this is going to be our solid. If you look at this second one, there's not as many, and they're moving freely, so that's our gas. And then C, they're not tightly together like they are here, but not kind of moving around as much as in B. So this is our liquid. So A, gas, nope, not that one. A, liquid, nope. So A is a solid, check, check. B is a gas, check. C is a liquid. All right, so it's going to be C. All right, 39. The graph below shows the solubility of two different chemicals. Let's take a look at this. Compared to copper sulfate, how many more grams of potassium bromide would dissolve at 90 degrees Celsius? So let's come to 90, and let's make a point here and a point here. So we want to know how many more. So let's take this over. We have about 60. This one's going to be a little bit more above 100. So let's say maybe 102. All right, so we would just subtract that. And then let's come look at our choices. 20, nope. 40, 60, 80. So we want to know how many more. So roughly 100 minus 60 gives us 40. All right, increasing the surface area of a solid, crushing into smaller pieces, slows down dissolving and decreases the rate of solution, speeds up the dissolving, causes the solid to ionize, or has no effect. Well, we know that crushing something into smaller pieces makes it smaller and easier to dissolve. Think about when we did the sugar crystal size. The powder dissolved faster than the larger size crystals, so that's going to speed up the dissolving. All right, so what you're going to do now that we've gone through all of these questions, take a couple minutes to review your notes, and then you're going to go ahead and take it again. All right, good luck.